Section 3.5 is titled Graphing Techniques, Transformations, and what we're looking at in this section is basically taking that list of that library of functions from section 3.4 and those different types of functions we looked at, like the square function or the cube function, and how to take those equations for those functions and manipulate them. And in doing that, we change the way the graph looks. And so we're going to look at how to take, something like f of x equals x squared, and maybe slide that graph up and to the right and stretch it out a little bit, or reflect it over the x-axis. And so different types of transformations. And so we'll start out looking at vertical and horizontal shifts. So how to shift the graph around, move it up or down, left or right. We'll also look at compressions and stretches, and then also look at reflections about the x and the y axis. And so let's look at this first example. First we're going to look at the vertical and horizontal shifts. It says, use the graph of f of x equals x squared to obtain the graph of x squared plus 3. And so if you'll remember, in doing this, a lot of times it's easy or helpful to look at like a table. Okay, so say we have x values of all these x values. We're just doing like an input-output table here. If I square those, that would be negative 3 squared is 9, and then negative 2 squared is 4. Square negative 1, you get 1, and then it's going to be 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. And so these are all points on that graph of f of x equals x squared. And our graph is going to end up looking something like this. And you should recognize this shape from that library of functions. It's the graph of that square function. And so that's the original graph. That's x squared. We want to use that to find the graph of x squared plus 3. And so if you think about what happens in the table here, I'm squaring my x value, and then I'm adding 3 to it. So really to kind of complete this table, if I want x squared plus 3, I just need to add 3 to this x value right here. So I've already squared it, now I'm just going to add 3. So I get 12, 7, 4, 3, 4, 7, 12. So I just added 3, 9 and 3 is 12, 4 plus 3 is 7, and so on to get x squared plus 3. And now what you'll notice is this new graph has a point at 0, this is the x value, 3. We have one at 1, 4, and at negative 1, 4. And then we have one at negative 2, 7, and positive 2, 7. And then one at negative 3, 12, and positive 3, 12, which would be, up here somewhere. And that graph looks almost exactly the same as my original, but it's been moved up. And how many squares or how many units did we move up? Well, from 0 here to 3 here, we shifted up 3 units. And you probably have made the connection now that when we went from x squared to x squared plus 3, we moved up vertically. It's a vertical shift. We went up 3 units. So if we just take our original graph x squared and put a plus 3 on the end, we get a vertical shift up 3 units on that graph. And you can imagine if I put a minus 3 on there, what that's going to do be a vertical shift going down 3 units. So that's how we do vertical shifts. You just add or subtract to the original function to shift it up or down. Pretty simple. So here, vertical shift down, use the graph of x squared to obtain the graph of x squared minus 4. All right, so and we won't go through all the process of making the table here. We should know that the graph of x squared looks like this. Okay, that's x squared. So if I want x squared minus 4, remember minus 4 is going to be a shift down, right? So I'm going to be here, and really I can just move all these points down 1, 2, 3, 4, 4 units. 1, 2, 3, 4, 1, 2, 3, 4. And it's just kind of a mirror image, just like this. And so that is x squared minus 4. Just moving that graph down 4 units is all we're doing. That's a vertical shift down 4 units. And so we kind of can generalize that. If we have some function f of x, the new function f of x plus some value is the graph of f shifted vertically up k units, whatever that k is. We're shifting up k units there. You know, that might be f of x plus 5 or 6 or 7. And then the same thing, f of x minus k, we shift vertically down k units. So plus k goes up, minus k goes down. Okay, let's look at a horizontal shift. This says use the graph of f of x equals x squared to obtain the graph of x squared minus, in parentheses, minus 2. So again, it's a good idea to look at the table here for this just to start out. So I'm going to make a little table here for all 3 of these. And let's start at, we'll just do it like we did the last one. Okay, x squared, we know those values from the previous. And so we know the shape of that graph. Looks like this. Now what about x minus 2 squared? So how are we going to figure that out? And so for x minus 2 squared, well, let's just think about if we were to plug in like the x value 0 here, what do we end up with? Okay. So plug in x value 0. 0 minus 2 would be negative 2. Square that, you get a 4. We'll kind of do this a few times and see if we can get a pattern here. Negative 1 minus 2 is negative 3. Square that, you get 9. Positive 1 minus 2 is negative 1. Square that, you get 1. 2 minus 2, 0 squared is 0. You might sort of see this pattern starting to form here. 3, if I do 3 minus 2, that's 1. Square that, we get 1. 9, 4, 1, 0, 1. 9, 4. Okay, looks like we've got a pattern here, right? So if I wanted to kind of extend this a little further, it'd be reasonable to guess that a 4 here would be a 4 here, right? Kind of looking at this pattern and this pattern. And if I go a 5, that's probably going to be a 9. So let me plot these points right here. Negative 1, 9. 0, 4. 1, 1. 2, 0. 3, 1. Hopefully you're starting to see that shape. 4, 4. 5, 9. Look at there. Got a parabola, but it's been moved to the right. And how far did it get moved to the right? Well, this point here was at x value 0. This one's at x value 2. Notice this, all these points got shifted 2 values to the right. And so just notice the connection here. I had a minus 2 there. It's not quite as intuitive as we'd like. You know, for the vertical shift, plus went up, minus went down. If we went plus 3, it went up 3. Here, if we do x minus 2, it actually goes to the right, so it moves it to the right. So it's a little counterintuitive. you would expect x plus 3 to go to the right, but here x minus 2 shifts this thing to the right 2 units. Okay, interesting. All right, let's look at this. Use the graph of x squared to obtain the graph of x plus 4 squared. Now again, we should be able to zip through this pretty quick. The graph of x squared, we know, again, that's that parabola. Okay, so if I want x plus 4 squared, notice the plus is in parentheses grouped in with the x there, not outside outside the square. A plus 4, that's a horizontal shift, and that's going to go to the left 4 units. Because it's a plus 4, it goes to the left. So this point right here at 0, 0, it's going to be moved to the left 4 units. This point gets moved left 4 units, as does this one, 1, 2, 3, 4. We can move this one. And then this point, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And here's our new graph, x plus 4 squared. We shifted it to the left 4 units. Cool. All right, so let's combine those together then. This says graph the function x plus 3 squared minus 5. So you got to think about what's our original function we're working with here. The x has a plus 3, and then outside of the square is a minus 5. Our original function here is still x squared, right? We've just added something to the x and put a minus 5 in there at the end of the function, but our original function is x squared. So we're going to start with that original function. Okay. And what we're going to do is think about what happened here. An x plus 3 in parentheses, isn't that a left 3 units? Right? We've took the plus 3, that means we're moving it to the left 3 units. And then when we do the minus 5, that part of it is a vertical shift. Oops. Five units down, right, from the minus 5 there. So what we need to do is take these points from the original function, x squared, go to the left 3 and down 5. That's basically what that says. So left 3, down 5, there's that new point. We just continue this process, left 3, down 5, left 3, down 5, left 3, down 5. Do that for all these. Kind of gets messy there towards the end, doesn't it? But if you'll notice, here's my new points. Let me do these in maybe a different color. Okay. And there's my new shape. My new parabola shifted to the left 3 and down 5. Again, compare that to the original one right here. So you can combine